Section 9.3, the slope-intercept form, y equals mx plus b. In this video, we are going to learn how to interpret the slope as a rate of change. We're going to learn to calculate the slope when I'm given 2 points that lie on a line. We're going to find the slopes and graph horizontal and vertical lines, and we're going to be able to recognize slope-intercept form y equals mx plus b and identify the slope and the y-intercept from that equation. So let's first of all discuss what the slope is. The slope is a ratio of the rise between 2 points to the run between the 2 points, or the ratio of the change in the y's over the change in the x's. So say that we have some point P1, which is given by x sub 1 and y sub 1, and then P sub 2 is x sub 2, y sub 2. So that's just any 2 points. Then here is the formula to calculate slope. First of all, we use the letter m to represent slope, and we think of slope as rise over run. And our formula to calculate the slope is that we take the y2 minus the y1 and divide it by the x2 minus the x1. So let's look at this visually. What we're looking at is we're going to have 2 points, some point 1, let's say here, that is written as an x1, y1, and then another point, let's say up here, that we'll call x2, y2. So if I calculate the ratio of the rise to the run of those 2 points, then that gives me the slope. So what I'm looking at is how much does it take to rise from one point to the other, and how much does it take to run or go horizontally from one point to the other. So let's look at finding the slope of a line given the points -1, 2, and 3, 5, and then we're also going to graph that line. So let's start first of all with our formula, which says that to find the slope, we use m equals y2 minus y1 over x2 minus x1. Now, it doesn't matter which point that you delegate to be x1 and y1 and x2 and y2, but you just need to keep in the same order, in respective orders, as you are computing these. So we'll call this x1, y1, and x2, y2. So to get my slope, I'm going to take my y2 value, which is 5, minus my y1 value, which is 2, and divide that by my x2, which is 3, minus my x1, which is -1. So 5 minus 2 is 3, and 3 minus -1 is 4. So then we say that my slope is 3/4. Now we'll look at this graphically by plotting our 2 points, -1, 2, and 3, 5. And now here's what our slope has told us, that if you start at, let's say this point -1, 2, to get to the point at 3, 5, you have to rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4. So this is what I have computed, is what is the ratio of the rise to the run. And then once I have my 2 points, I could go ahead and draw my line between those. And there's a line that has a slope of 3/4. Now let's do the same thing, but let's use the points 1, 3, and 5, 1. So again, my formula is m equals y2 minus y1 over x2 minus x1. So we'll make this x1, y1, x2, y2. So I'm going to have 1 minus 3 over 5 minus 1. 1 minus 3 is -2. 5 minus 1 is +4. So that actually simplifies to -1/2. So then I would say that my slope would equal negative 1/2. So now let's look at this graphically. If I take the point 1, 3 and the point 5, 1, and then look at my rise and my run, since my rise is negative, then that means we're going to go down first. So I would go down 1 over 2. Now notice that that does not put me at my other point. But if I go from that point down 1 and over 2, that does get me to my second point of 5, 1. And all of those points, if we go ahead and draw our line in between there, all of those points are going to lie on that line with a slope of 1/2. And that's the thing that's important about lines, is they have a constant slope. So if you pick any 2 points on here, the rise and run will always be down 1 over 2. Or we could go up 1 and over negative 2, because that would be the same fraction. Negative 1 divided by 2 is negative 0.5. And 1 divided by negative 2 is also negative 0.5. And that is one thing that's important about slopes. We do want to keep our slopes in fractional form because they're easier to count off your rise and your run. So let's look at some notes about calculating slope. Lines that have positive slopes will go up or increase or rise as we go from left to right. So if we look at our line from left to right, positive slopes will go up. If we look at our slopes from left to right and they're negative, you're going to find that your line will decrease or fall from left to right. So a positive slope will increase or rise. A negative slope will decrease or fall. Now we need to talk about what happens when you have horizontal and vertical lines, because those are special cases of slopes. So let's think about this graphically. If we were to have a horizontal line, so let's say that that's my line. Let's go ahead and label this as my X and my Y axis. Notice that if I pick 2 points that are on that line, that if I start looking at the slope of those, between those 2 points, if I do rise over run, the rise on this is 0. So when I do rise over run, I'm going to get 0 over some number, but that's 0. And notice that when you have a horizontal line, the slope is 0. And you also need to note that the equation of a horizontal line is always of the form y equals a constant. Now, what if I have a vertical line? So let's say that we now have, instead of a horizontal line, we're looking at a vertical line. Well, if I look at 2 points that fall on that line, if I start doing the rise and run, these do have a rise, but there's no run. So what happens there is you're going to get a number divided by 0. But we know that when you divide by 0, that's undefined, which we can mark with 0 as 0 with a slash through it. So vertical lines are always going to have slopes that are undefined, and the equation of a vertical line will always be x equals a number. So looking back at my 2 examples, if I look at my first equation, which was a horizontal line, that might be, let's say, reasonable to be the line y equals 3. And let's say this vertical line that I have would be something like maybe x equals 2. Vertical lines are x equals a number. Horizontal lines are y equals a number. Now, let's look at some examples. Find the equation and the slope of a horizontal line through negative 2, 5. Well, since I want a horizontal line, I know it's y equals a number. So if I go ahead and look at this graphically, negative 2, 5 would be here. I've got to go through that and be a horizontal line. Well, that's going to be a graph that would look like this. And if you look at that, that's the equation y equals 5, because that's the y value of your ordered pair. Now, if we look at the next example, we want to find a vertical line that goes through 3, 2. So let's plot that. So there's going to be my line. And we know that vertical lines are x equals equations, and that has an x value of 3. And now we can go back and find our slopes. So looking at our first one, since it was a horizontal line, we know that the slope will be equal to 0. In the second equation, since we know that we had a vertical line, we know our slope will be undefined. Now, in our last video, we talked about something called standard form. In this video, we're going to discuss something called slope-intercept form. Slope-intercept form is always of the form y equals mx plus b. What you are finding when you're given slope-intercept form is it very quickly points out to you what the slope is. So your m is going to be your slope, and your b is always your y-intercept. Now, using slope-intercept, it allows us to quickly graph lines. So if I take the equation negative 2x plus 3y equals 6, and I want to find the slope and the y-intercept. First thing I want to do is put this in the form y equals mx plus b. In other words, I want to get the y variable by itself. So what we're going to do is we're going to add a 2x to both sides. So this side will cancel and give me 3y equals. Well, I can't add 6 plus 2x and simplify. So let's put 2x first, because we want it in mx plus b, and then plus 6. Then to get y by itself, I would need to divide by 3. So I'm going to divide everything by 3 and get y equals. 2 divided by 3 doesn't divide nicely. Let's leave it in fraction form. Don't change that to a repeating decimal. But then 6 divided by 3 does divide nicely into 2. So now I can find my slope, which will be 2/3, because m is the constant or the coefficient in front of x. So there's m. And b is my y-intercept, which is here, 2. Now I can use that to help me graph. So what you're going to do is you're going to start at the b value of 2. So think of that as where you're going to begin. You're going to begin at 2, and since it's a y-intercept, it starts on the y-axis. So we're going to go to the y-axis at 2, and we're going to plot a point. And now I'm going to use the slope as 2/3. Well, if we remember, that's the rise and the run. So we could go up 2, rise 2, run 3, over 3. So up 2, over 3, put a new dot, and there's another point on that line. So let's try that again. Up 2 more, over 3, puts another point. So now I've got 3. I could have also gone down 2 and over negative 3, because if I think about that, negative 2 divided by negative 3 is the same thing as positive 2/3, because a negative divided by a negative is positive. And now I have several points that I could go ahead and connect and make my line. So my line would fall through those points. Put our arrowheads on the end. And there's the graph of the line. Let's look at another example. We have x plus 2y equals negative 6. So we want to find the slope and the y-intercept, and then we want to graph. So let's get our y by itself, because we're looking for y equals mx plus b. So we'll start by subtracting 6. So 2y equals negative x minus 6. We'll divide by 2. Y equals, now let's think of that as negative 1x. So that will be negative 1/2 x. And then negative 6 divided by 2 would be negative 3. So we have minus 3. So my m is negative 1/2. And my b is negative 3. So let's plot this. We're now going to begin at -3, so that's where I start on the y-axis. And then the m is going to tell me how we move. So we go down 1 over +2. And I can do that a couple times. Or it could have also gone up 1 and over -2. Because again, -1 divided by 2 is the same thing as +1 divided by -2. And notice that I can quickly come up with several points. And now I just connect those points and I can form my line. Now, what if they give me information and want me to write the equation of a line in the form y equals mx plus b? It says find the equation of the line through the point 0, -2 with a slope of 3. Well, I know that that tells me that m is 3. And if I think of this graphically, 0, -2 would be over 0 down 2. So if I'm plotting that point, that's going to put me right there on the y-axis. So they've actually told me what b is. Well, once I know m and b, I can just write the equation then. Y equals, we found that m was 3, so this will be 3x plus b, but b is -2, or y equals 3x minus 2.